Okay, so our next speaker is Ben Zvan. Some of you, Ben, come on up, come on up. Some of you may have seen Ben walking around taking photos at DevOps Days Minneapolis because he was our official photographer.
I look more like this at that point?
Yeah. Oh, no, he has one. Let's see, is your mic on?
I think it is.
Excellent.
I thought I heard it. Yeah, okay.
Seamless transition. This is great. And the reason I'm excited to have Ben give this talk is I've actually seen this talk. So, and I think are you workshopping this? Because I know you're going to be giving it at least one other DevOps Days too.
Yeah, I think it's a fun topic for me. So whoever wants to hear it, I'm happy to talk about it.
Absolutely. Okay, so without further ado, Ben Zvan.
So I am here to tell you when the fit is a graph database. And I want to start out by saying that I have no credentials to talk about this topic. I'm not a DBA. I'm not a data architect. I am an ops guy at Target. I do container orchestration for a living. And I just happen to think that graph databases are a pretty cool idea. And I wonder why they aren't used more often than they are, because databases make people really angry. I mean, DBAs have to get up at 2 o'clock in the morning to make their changes, because if they alter the wrong table in the wrong way, everything is down forever. Or they have to do a giant migration and it's going to take them 8 hours and they have to start at 5 o'clock at night on a Wednesday and it actually takes until Monday. So graph databases, I think, have a potential to fix a lot of that. Now, a little bit of history. About 6,000 years ago, we started writing stuff down. Round about the time of Lincoln's assassination is when Oracle came up with the first database. And then in the 1960s, this is actually true, in the 1960s was the first graph database. So they've been around for quite a while. So 5,000 to 6,000 years ago, when we started tracking data, we wanted to just remember stuff. And a lot of the data that we were tracking was really mundane. It was things like bills of sales and ledgers, and it's not romantic, but all of this is probably somebody's bill of sale. It looks really cool, but that's really probably all it is. And as time went on, we kept on making more and more data. And this is a ledger. Unfortunately, I think it might be a slave trading ledger, which makes me feel a little sad. But it's a single table time series database. And it's really basic form of data, and you can track it really easily. You can write it on paper, you can carve it into a rock, whatever's handy. But as time went on, this data became really critical to our businesses, and they were real things in a searchable form. You could use your ledgers and your data to figure out how to optimize your business. I sold X number of products and I'm going to sell X number over the next 2 weeks. I should probably order more so I'll have them instead of waiting until the shelf is empty. So when you try to get that kind of information out of a single table database, it's kind of hard. You could have this as a spreadsheet, you could have it as a ledger on paper. But your time series is super easy to search because it's the order that you entered it in and it's already basically indexed. If you move on to things like who bought things, it gets a little harder because that's not really in order. If you're in a spreadsheet, maybe you can sort it. If you are looking at what they purchased, if you have multiple items in a single entry, which actually didn't happen that often, it gets really, really hard to search. So you enter the relational database. A relational database basically allows you to take that data, that table, and break it up into logical groupings of separate tables. And then you can use a primary key to make links between them. And you don't even have to have a relational database. I think databases like Oracle that call themselves relational databases are really just databases with multiple tables and keys. And you can do that in anything. You can do that in Excel if you really want to. I wouldn't recommend it, but you can. So as you have all these relationships, you start realizing that there's a lot of data that you can get out of there, and you can dig down pretty deep, and you can find all sorts of information about the stuff that you're working on. You can figure out what your velocity of sales is. You can figure out who your customers are and how they need to be served better. You can find out who needs attention and who doesn't. Some of the relationships that you discover may not be useful. They may not actually have a cause and effect relationship. But most of the relationships that you discover are going to have some value. I mean, even though there's obviously no cause and effect relationship to this, I think everybody in the room probably has heard of it before. Amazon, for example, has done a great job of making literal value out of these relationships. They turned a $20 sale into a $46 sale by saying, I'm buying rust, so I'm probably going to make thermite out of it. Unfortunately, as your data set becomes more complex, as your searches and queries become more complex, and the data that you want to get out of it becomes more complex, your response times go way up. I had a daily job that took 25 hours to run. That's not sustainable. You have to figure out how to fix that, and it's really difficult in some cases with a relational database. So the graph database elevates those relationships to a first-class organism in the data structure. You have two types of objects. You have nodes and relationships, and that's it. So instead of doing a query that goes across multiple tables using primary keys and outer joins, inner joins, all these kind of nested selects, you can just ask, what nodes relate to this node in this particular way? And you can have multiple different types of nodes. You can have multiple different types of relationships. And you can ask, which of these orders have mega widgets? These 3 orders have mega widgets. 2 of them have hyper widgets. Maybe we should suggest a hyper widget to this person. And maybe we'll get an extra sale out of it. And if you try to do that in SQL, it's really hard. You can do it, but I tried to read through this a couple of times. And again, I'm not a DBA, but I tried to read through that a couple of times and I did not get it. This one, which is, I actually stole this entire slide directly from Neo4j, which is one of the graph databases that you can use. But their Cypher language, this is actually pretty readable, and you can see basically what it's saying is, it's saying this. Who's buying stuff, who's bought stuff in the past, and what are their relationships to each other. And one thing that I wanted to stick this in there because I think it's really cool is the GIS data is a really good fit for a graph database, because if you plot out your GIS graph in a relative spatial relationship, you actually get a real map. If you use XY coordinates that are already in your data and distances and all that kind of stuff, you actually end up with a map. So when is the fit a graph database? When relationships are as important as your data, when you have many-to-many relationships, and you can find that out when you have tables that have no actual values. They're just primary keys from other tables. So thank you very much. I hope you've learned about graph databases, and I hope that you consider using them.
Someday I'm going to get good at turning these back on. Someday I'm going to get good at turning mics back on. The day's clearly not today. So I feel like this is the kind of thing where you're like, that was hilarious. I have so many questions, but maybe they start with, for people who are a little bit unclear as to how, like if their database hierarchy of needs goes, there's MySQL and MongoDB and ... profit. Like, can you kind of just explain what makes a graph database? You alluded to it a little bit there, but maybe a tiny bit of Q&A. I know you don't usually have that for Ignite, but a little bit.
That's fine. And I am going to preface this once again with, I am not a DBA. I'm not an expert on graph databases, but I've used a few of them in the past. So a graph database really does take the node and relationship concept. If you look at GraphQL or I'm trying to think of Wolfram Alpha has a Facebook relationship visualizer that shows you a graph of your friends and their friends, and it shows basically a bunch of circles and lines, and each friend is a node, each line is a relationship or a friendship as far as Facebook considers it. So using that data, that node still has all of its metadata about it. Things like name, user ID, all that kind of stuff. And it has references to maybe other nodes with like city or likes or that kind of thing. And then it has that main friend relationship that I would consider the main part of Facebook. I'm going to pick on for an example here. But so yeah, basically it's a different way of visualizing your data and storing your data so that the relationships are an inherent part of the data instead of a grafted on chunk of metadata. Because as I said, you can take any table and you can put a primary key from another table, some sort of line number from another table, and put it in there, and you've created a relational database. But what you've really done is pretended that you have a relationship. You've just sort of made a pointer.
Okay, we have a couple more questions.
So like, there's lots of graph databases. Do you have a favorite?
I've used Neo4j. Primarily, I've used Neo4j. I've used a couple of JavaScript graph visualizers, which just use a JSON backend. And I think most graph databases will produce JSON as output, so you should be able to use really any one that you want. I had some experience with Neo4j as our first graph database at the previous place that I worked, not at Target. And it seemed pretty straightforward. It had some weird things, like it has no concept of security. Maybe that's been fixed by now, but if like, yeah, I think that's actually accurate.
Security is an optional later added feature.
Yeah, like if you could connect to the server, you could do any query you wanted to. Because actually, security in a graph is really difficult. Because if you have the way that they do it. Yeah, the way that they do queries is when you look at a node and its relationships, it also looks 2 nodes out. So if you're doing that relationship, if you have access to this node, and you don't have access to any of the nodes that connect to it, how do you actually get a result? So it gets really difficult, but at least having the ability to log in and authenticate would be nice.
Oh my gosh, well, I think people are going to want to chat more about that, perhaps over the rest of the beers, but give it up for Ben.